Two and a Half Admins, episode 89. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And before we get started, your customary blog post plug, Alan, is learning the fundamentals of the Freebsd shell.
Yeah, so in the next major release of Freebsd, 14, when it comes out next year, root's default shell is switching to plain Bourne shell, so bin.sh instead of the C shell.
Finally.
Yes. Mostly the main reason is that the Bourne shell finally got enough work that all the day-to-day things you need in it are there now, like the history editing and command buffer and all that stuff. And it's actually usable as your day-to-day operational shell and not just the target for your shell scripts anymore. But anyway, the article goes through the basics of the shell and also some comparisons of Bourne shell versus C shell. So it also answers some questions like, why does redirection not work on FreeBSD as root? It's like, yeah, because that's a different shell and it uses different stuff. And even the for loops are different. I once learned how to do for loops properly in C shell and then promptly forgot and went back to just using sh-c to write my one-liners.
I learned C shell before Bash because I really began my journey seriously as a FreeBSD person. And it took me like 10 years to recover from that mistake.
All right, well, link in the show notes as usual. Let's do some feedback. The first was a tweet from Glenn, who wanted to know our opinion on CDRs and DVDRs versus Blu-Rays for longevity.
I remember when CDs, like not even ours, just CDs, ROMs first came out, and we were promised that, you know, they would maintain their data for like 100 years. And then CDRs, we knew that it was never going to be as good as a pressed CD, but it was supposed to keep your data for as long as you would need it, right? And it very much did not.
Even if you can keep the surface of them clean and clear, which is impossible already when you have a family that likes to pull them all out of the case and just stack them naked on a car seat or whatever, you've typically only got maybe 5 to 7 years before the dies have degraded to the point that the disk is no longer usable. So then they came out with archival CDRs that cost much more, but were going to give you that, you know, decades of longevity that you were promised to begin with. And it turned out that most of those, all they really accomplished was costing a lot more. Some of them didn't even last as long as some of the brands of, you know, just normal CDR. Then when DVD-RW came out, these claims were made that, oh, well, because the dies are different and the manufacturing techniques are different, you know, DVD-Rs will give you that longevity that you always thought you were going to get. And that turned out not to be the case. Then when writable Blu-ray technology became a thing, once again, it was, well, this is different. You know, the dies are different and this is this and this is that. And it turns out, yet again, some brands last longer than others. You don't really know which ahead of time. And quite a few of these that, again, were, you know, promised to give you all this longevity don't even last as long as most of the CDs or DVDs did. I think ultimately it comes down to, you know, you can't blindly trust optical cold storage any more than any other kind of cold storage. You don't really know how long it's going to last until the first bunches of them start failing. And especially when you have a medium that promises you it's going to be fine for decades, that means you've got a long time from when the product is introduced to when you can really be certain it's going to live up to its claims. Because they'll try to do accelerated aging tests to, you know, back up the idea that they have of how long their medium will truly last. But the accelerated aging tests aren't always all that accurate, and a lot of manufacturers don't even bother to do those. They just make claims and go.
At best, it's an extrapolation, and it means any errors are hugely amplified.
Yeah, like have you ever had something plastic that's been hidden away somewhere in a box or whatever for years and years and years? You get it out and it's weird and sticky.
Mm-hmm.
Like there's just sometimes just things age weirdly.
Yeah, I had a lamp that I had in my room, and the base had this cheap plastic on it, and it turns out it was filled with like clay or something as a weight for the bottom. And eventually the plastic just got old and literally crumbled into pieces. When I picked up the lamp, it was just gone, and there's just this lump of Chinese clay sitting in my living room floor.
So at my current largest individual contract, I spend a good bit of time there every day. And we had a problem for a while. One of the very long time, very valuable, very important employees, her network stack just kept dying on her laptop. And people had been messing with it and messing with it and messing with it for months. But, you know, it's one of those situations where her office is, I I really can't accurately describe the wiring situation in a family-friendly way. And nobody had done the work of actually tracing all the wires back to figure out what's plugged into where and, really properly troubleshoot everything. So then I come into the picture and people have been trying to fix this for months, but nobody had the will to do that. And I'm like, okay, I don't care how messed up this is, how many desks I have to move, how far I have to slide my hand literally gripping a wire to make sure I'm on the right one to get to the other end. I'm going to chase this back. And when I did that, I finally got all the way back to the wall where her laptop was plugged by way of like a 25-foot Ethernet cable into the wall jack. And I can't stress this enough, I very gently pulled on it thinking maybe the tab has been crushed on the cable and the cable will just pop out without having to pull the tab in. It's a very common failure mode. And instead what happened is the whole freaking wall jack, the keystone, just came out still attached to the cable. So, there's like, a wall plate with no keystone in it. And the whole thing has just come off. And I'm like, well, there's your problem right there.
Yeah. So ultimately, when it comes to long-term storage, we've talked about this several times, cold storage is just not really to be relied upon. And hot storage that is being checked regularly, whether that is with ZFS or whatever, that's what you would recommend, both of you, right?
So the thing about cold storage is cold storage can be much cheaper than warm storage if you can absolutely categorically trust it for long periods of time. But you really can't. Like, if you're going to try to do that, you have to be working with media that has been well understood for decades. And media that has been well understood for decades is generally, it's much too small. The closest thing we have to that right now is LTO tapes. We understand their degradation pretty well. And, the actual medium hasn't really changed too much as the capacities have gotten larger. But, even then you're talking about, okay, so maybe we can trust LTO tapes for long periods of time. But in order to do that, you're also going to need extremely well climate controlled and like magnetically environment controlled conditions, which means you're going to be storing them at some place like Iron Mountain, which means a whole lot of what was supposed to be cheap to start with has just gone right down the drain. And if you guess wrong about any of that, your data will be gone. You can try to work around that by storing your cold stored data redundantly in multiple physical locations in much the same way we talk about doing a 3-2-1 for backups to begin with. But the nasty part about it is if you truly hold that data to be mission critical, it's cold storage, sure, but it has to be available. Well, you have to check it. And if you have to check it, the expense of really slow to access, cold stored media that doesn't have enough hardware to access it all at the same time, by the time you actually do that audit, you can very quickly discover that, your once every 10 years audit actually cost you more than just keeping that data warm the entire 10 years would have. And while you have it warm, you can actively monitor it. You can actively correct errors with redundancy or parity. You can actively back it up. All these things that just, once you say cold storage, none of this is an option anymore. You're chucking it in a hole and hoping it'll be fine when you get around to it.
Yeah. Whereas warm storage, you've got Nagios telling you the minute anything goes wrong with it.
Exactly. You're checking it constantly. And because you can automate the way that it's checked constantly, it's cheap. It's really cheap. And in a lot of cases, you may find you can actually store a given number of terabytes of data more cheaply in a couple of servers with large, nice and cheap Rust hard drive arrays. The cost of the power to keep that server running and the space to keep it running, it may not even be any more expensive than it would cost you to maintain that same data cold at a proper cold storage facility like Iron Mountain.
It's literally really the cost of keeping the lights on. And the advantage is that you're getting to check it. And it's like you're saying, if you're doing cold storage, it's like, sure, you could use some kind of optical media and then like once a year try to read it all back and write it to new disks so that you know that maybe it'll keep lasting. But once you have enough redundancy to know that, all right, if that one disk doesn't read, I'll be able to reconstruct the data from weird parity thing I've manually set up or extra copies I have. You're going to be spending so much time managing that it would have been a lot cheaper to just have warm hard drives that tell you when there's a problem instead of you having to go out and check it constantly and always knowing that you can never be 100% sure your data is still going to be there.
Yeah, I first encountered this in a university project. The archival department at the University of South Carolina was looking for a way to maintain voice recordings for very long periods of time. And I tried to come up with a cold storage method that I could trust for that. And every time I did the math of what it would cost, it came up far cheaper to just store it on live servers. And that also gives you the option. This was particularly attractive for university environment. You have the option of, if you can get other universities on board with your plan, you can do replicated backups between the universities, and each of you can serve as the other's backup, which makes it even cheaper again. And that's a situation that I encounter a lot in business as well, because so many businesses have multiple locations. And if you have multiple physical sites, well, you don't really need to back your data up to the cloud, because your other site can be your offsite backup.
Okay, Josh writes in, what are your thoughts on CubesOS? Or more specifically, does the use of a Type 1 hypervisor and integrated VM management bypass most of the actual security concerns regarding sandboxing, i.e. snaps, flatpaks, Docker, etc.? While it is arguably too resource intensive and technical for most people's general use, the ability to create, manage, and isolate various VMs for effective isolation between domains seems perfect for individuals who need additional security, i.e. activists, high-profile targets, who deal with questionable material regularly, like journalists and security researchers, or have very technical jobs, like numerous specific configurations for different clients, different build environments, need to routinely test things in VMs. It's definitely above my head, and I'd never heard of it before, but I don't recall you all talking about it. While no OS is a replacement for backups, appropriate system design, and routine maintenance and testing, I feel like CubesOS might be interesting or appropriate for some DevOps and sysadmins on their personal systems.
As the resident VM guy, for lack of a better term, I have to preface my remarks with saying I've never actually used CubesOS. I'm familiar with the concept as a project. I know it exists. I have not fired it up on my own equipment. I think my biggest concern is that Josh may have the security thing backwards. Josh says, does the use of a Type 1 hypervisor and integrated VM management bypass most of the actual security concerns regarding sandboxing? My concern is that the deeply integrated VM management is more likely to bypass most of the actual security, period, in the sentence there. The more you integrate agents and two-way communication, baked into a virtual machine, like, for example, what Windows does with the Windows subsystem for Linux. It's actually a Linux VM, but it's extremely tightly integrated into the Windows operating system to the point where you don't really notice most of the time when you're crossing the layers. You can just copy things automatically, in between the VM and the Windows host, or vice versa. They communicate in all kinds of ways without you having to stop and think about it. And that's convenient for use, but it would make my teeth itch if I was actually relying on that VM isolation as a security feature, because you've just poked a tremendous number of holes in it. I do think there is absolutely a lot of value in doing questionable work inside a VM. I just don't think I really want that VM integrated in with the host environment. I want it as separated as it can be. I want to have to open up a console window into that VM and, basically interact with the VM via SSH or remote desktop or what have you. And the less that it can impact the host operating system, the better. It's fine for the host to be able to poke inside the VM, but once you start doing anything that you call tight integration, you start opening up more and more holes where the VM can actually reach out and poke at the host operating system. Because if you've only got that communication one way, it doesn't hit that convenience factor that everybody's looking for and say, oh, everything's all built together. So I'm a little dubious about Cubes. I think it's certainly an interesting concept project. I have difficulty imagining something I would personally want to use it for in real life via just spinning up VMs in a more traditional VM hosting environment.
Well, it seems Cubes is kind of trying to take the microkernel idea, but do it with VMs. So like it has one VM that's just responsible for your USB stack, and then it uses software to connect that to the other VMs. And, they talk about using that to allow access to a U2F device from your browser that's running in a different VM without exposing the entire USB stack to the VM that has the browser in it. So the browser's compromised. It can't access your USB stick, but you can still log in with your U2F token. And then, they have another VM that's the network stack and another VM that's the firewall. And I don't know, it feels a little weird. The idea with a microkernel is that, that thing can crash and come back up and not take out the other stuff. And that kind of works that way with VMs too. But I agree with Jim that having a bunch of separate VMs and having isolation will maybe help with that security, but then it tries to do things like the app cubes and so on to share the root file system across all those VMs. And then once you're doing that, you're kind of eliminating a lot of the security you got by separating all those VMs when you've plumbed all these different ways for the VMs to talk to each other.
Yeah, if you can start out from the VM and either get a shell or mount the root file system on the host, you've gotten rid of 99% of the security effectiveness of the VM isolation.
Well, in this case, because it's using Xen and the way Xen works, there isn't really a host quite there. So Xen is basically the operating system, and then it's loading other bits. And so there's one VM for the GUI and one for the system management stuff, and those are running Fedora. And then you have your app VM that's running like Debian, and that's where you run the applications. And so there isn't really much that's actually in the host OS. It's basically just the hypervisor, kind of like a ESX or whatever. The OS is actually stripped down to basically nothing other than the hypervisor, and then everything runs in a VM. And you just end up with running like 12 VMs on your laptop. And it's like, well, am I just, partitioning up my limited resources too much in that case?
Yeah. You're effectively going to end up with something that you consider your root file system no matter what for all this stuff to interoperate properly. And I mean, I've already said it. By the time you're doing that, by the time you can get a shell from one to the other, or you can mount one's file system from another, you've pretty much blown away the barrier. At that point, you would probably be better off with, a more traditional sandboxing that's actually designed to be a sandbox. I don't know. I don't think it was ever really intended to function that way. You're starting out saying, oh, well, I don't like chainmail because plate mail is stronger, but plate mail is too heavy, so I'm going to drill lots and lots and lots of little holes in it. So, when you're done, all you really have is much, much, much less battle-proven and tested chainmail.
It reminds me a bit of this laptop concept that some German company was doing. I think it was called L4 or something. And they had a kind of similar concept where there'd be like a BSD VM that was the firewall, as if it was almost like a hardware firewall or something. And then they have, I think, 2 Windows VMs, a secure one and an insecure one. And only the secure one was actually connected to the company VPN. And that's where you could do the company stuff. And then you pressed a button, a key combo or whatever, and it switched to the other Windows VM. And that's where you could do your other stuff that wasn't locked down.
This is the way.
Yeah. And they had that. And it's kind of seems like that concept, but made more general and done with a lot more VMs instead of this 3. But if you have one for the firewall and you're just going to say, 512 megs of RAM or whatever, and then you're just going to split the other 2 in half, that still seems reasonable. But if you end up with 10 VMs like they have in this diagram here, and, 5 different levels of trustedness, your laptop only has so many gigs of RAM. And if you're slicing it up that much, you end up with not enough left to do what you want to do with it.
I will say, as far as splitting the resources up, it's been a long time since I've used Xen in Anger, but I've got to believe it's got a similar functionality set to KVM in the sense that you can share RAM between VMs. You don't have to just allocate this VM gets 8 gigs of RAM and that's it. They can actually balloon in and out. So as long as you've got enough memory for all of them, you've got enough memory for each of them. So that alleviates a good bit of that concern.
But you don't want to be stealing RAM from your firewall VM either.
Yeah, well, we're kind of back then to whether you want to admit to it or not. There's always an upper level. There's something that you have to consider a host. When I provision VMs on my systems, I starve the crap out of them for RAM when I don't have a client overriding me who thinks they know better. And there's a reason for that. When you've got more than one VM on the system, if you only give it enough RAM to run its applications, then all of your caching happens at the host layer. And when your caching happens at the host layer, the host can figure out which VM stuff is actually getting hit more often and really needs to live in the cache more. Whereas if you let each VM do its own file system caching, which is the only reason to give them more RAM than they actually need to run the applications, well, then they will cache only their own crap, regardless of whether it's ever actually getting used or not. So it's inefficient. It doesn't survive reboots of the VMs. That's the other advantage to doing your file system caching at the host level. You can bounce your VM and the caches are still hot.
Yeah, we talked about this I think 2 weeks ago when you weren't here as well. Basically, exactly the same thing with the small caveat that if each of the VMs belongs to a different person, sometimes you want to make sure that the guy who's busy isn't stealing all the performance from the other people. And that's why you might actually divvy up the RAM. But in most cases, yes, you're going to get the best results by having all of the spare RAM on the host for the caching, especially if you're using ZFS, where it's going to make much better use of that RAM with a smarter caching algorithm.
Well, if it's on ZFS, you just go over the data set of that guy that just keeps consuming all the resources, and you set cache equals metadata. Problem solved.
Okay, this episode is sponsored by Linode. Go to linode.com/25A, support the show, and get $100 free credit. From their award-winning support offered 24/7, 365 to every level of user, to ease of use and setup, it's clear why developers have been trusting Linode for projects both big and small since 2003. Deploy your entire application stack with Linode's one-click app marketplace, or build it all from scratch and manage everything yourself with supported centralized tools like Terraform. Linode offers great price-to-performance value for all compute instances, as well as block storage, Kubernetes, and more. Linode makes cloud computing fast, simple, and affordable, allowing you to focus on your projects, not your infrastructure. So go to linode.com/25A, create a free account with your Google or GitHub account or your email address, and you'll get $100 in credit and support the show. That's linode.com/25A. Okay, Scott writes to us, a little cherry on top for your barter to Bitcoin rant. In Chapter 2 of Debt, the First 5,000 Years, anthropologist David Graeber laid out how the idea that before money, people used to barter directly was a complete myth. So the premise of the book itself, a progression of barter to money to cryptocurrency, is nonsense. Though I get that's probably heady reading for your typical crypto bro, lol.
The book that Jim was talking about was targeted at like 10-year-olds too, wasn't it?
Yeah.
Well, Robin suggested that Jim should debate Chris Fisher about crypto, and Mark thanked us for speaking out about Bitcoin propaganda, and he also mentioned Jupiter Broadcasting. For those who don't know, Chris over there, who's my friend and I contract for with a bit of editing work, he is kind of all in on the Bitcoin thing, and obviously is a well-known podcaster as well. But I don't think we're going to be doing any sort of debate. I don't think there is much debate that I want to have, and I don't really want to sort of platform that other side, really. I would
just like to point out that Chris is also kind of high on ButterFS.
But we can't just make a whole episode about how Chris is wrong. That would seem unfair.
Well, yeah, I think I said this on Late Night Linux. I think Chris is wrong about it being the future of funding anything legitimate.
To me, it would just feel like, you could have a debate about if the moon landing was faked, but you're going to surface some new evidence? Like, what's the point of the debate going to be? I don't think either side's going to come away feeling like they learned something, other than that was a waste of time.
No, probably not. And, I will say this. I think it's a little too strong to say that there will never be any viable cryptocurrency. I don't think that's been thoroughly proven yet. I think there's still a possibility for proof of stake to be a win and to end up being something that's actually usable and useful without just slashing and burning miles of rainforest to generate it. The problem is that proof of stake is still an idea. It's vapor. Ethereum has been saying they're going to go to proof of stake for years, and it's just perpetually 6 months away. Even after they move to proof of stake, nobody has said anything about how you're going to actually get everybody to use it when so many Ethereum users are actively declaring that proof of stake is garbage and they'll never go to it and you have to proof of work. Now, granted, most of those are Bitcoiners. They're not in Ethereum at all, but we've already got evidence that you can't really force people off of it in the fact that Ethereum Classic still exists. Ethereum already forked once, and it didn't even fork for as awesome a reason as, not gobbling up all the electricity it possibly can, by move of proof to stake. And the last time it forked, Not only did an awful lot of users not make the transition, they're still running the classic blockchain. So, I don't know. Once anybody has actually implemented proof of stake, and we've seen it fix the energy problems, well, that'll be great, and we can talk about that. But until then, this space is completely freaking occupied by grifters. And the grifters all say everything is already awesome, everything will be awesomer tomorrow and the day after, and you can't wade through all that. Somebody's going to have to actually prove it. Somebody's going to have to show me faster transaction times and no, the freaking Lightning Network doesn't count. They're going to have to show me lower energy consumption and no, not just say proof of stake will fix it, implement it. You're going to have to get your users to use your proof of stake. Again, I'm from Missouri for the duration of this rant. Show me. I'm not believing it before it happens.
Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. You can go to 2.5admins.com/support to find out more. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. And if you want to send any questions for Jim and Alan or your feedback or anything really, you can email show@2.5admins.com. Daniel writes, I'm contemplating moving my home server from Proxmox to a bare metal Ubuntu server. Right now, I only have about 5 machines going, all running Ubuntu Server 2004 LTS. One is running an SMB share with a handful of drives passed to it. The others are just running boring things like Pi-hole, a Git repo, transmission, and a certificate authority that I never had the time to get up and running. Before discovering Proxmox, I had this machine running Ubuntu Server, but I balked it somehow because I think I had too many things that all wanted to use web servers, and I think one of them ate another. So the new plan is to learn containers and use that for segregation instead of VMs. Anyhow, the real question is there a good way to save or export the machines so when I start making containers, I can at least copy-paste the necessary configurations instead of building everything from scratch?
So it depends. Jim, do you know in Proxmox, how are the VMs stored? Is it like a QCOW file or?
There are different backends available. I know that Proxmox has a baked-in ZFS backend storage mode available. It may or may not be what Daniel is using. I believe that Proxmox's baked-in ZFS backend option uses zvols, but I will not swear to that.
I think I've seen the same thing somewhere.
Yeah. I know that in some configurations it will use QCOW2 files, but I think the most common one these days is with ZFS built in and in turn using zvols. So the way to save those there are a few ways. It gets pretty complicated because you're saying that you want to save the actual machines to turn them into containers. And I don't know that I can really help you with containerizing the VMs. That's just not a direction that I've personally gone. I don't do a lot of Docker or, LXD, LXC, any of that kind of stuff. So I can't give you too much direct advice on that part of it. As far as preserving the virtual machines themselves, that part's pretty easy. You need to find an XML file that actually defines the virtual machine's hardware configuration. On a standard Ubuntu, that would be under etc libvirt QEMU. Proxmox may have that hidden away somewhere else, but it should still be using the standard KVM style XML file. So you find that, and that will give you your hardware definitions, which includes everything from just where your drives lived. It will also tell you things that aren't necessarily as easy to recreate, like the MAC address for your virtual network adapter, without which your network configs won't quite work right. Now, it's not usually the end of the world if you lose the XML file, but you do end up having to deal with things like on a Windows VM, it will treat it as a brand new network interface that's on DHCP no matter what, because it doesn't recognize the MAC address, so it assumes it's a new adapter you put in the system. Meanwhile, your old configs are still on what Windows thinks is your old network card that might show back up at any time, so you can't even immediately set the IP address on the quote new unquote adapter to the same one as you used on the old one, because the ghost of the old one still lurks in Windows internals and it says that IP address is already assigned to an adapter and you've got to deal with all that. So it's really nice not to have to go through all that and to have that XML file handy and available. That's just a little tiny XML file, very easy, copy it, you're good to go. It'll work on any KVM system. Now, as far as the drives themselves, you've got several options. I'm just going to assume that we're talking about, ZFS and zvols for the back end. You can replicate those off to another ZFS machine is going to be by far the easiest way to deal with just preserving it and making sure that you still have that actual storage. And again, that is by far the most important part of the VM. You still have the VM if all you have is that ZVol. If all you have is the XML, you don't really have anything worth having. Your other options, if you don't have ZFS on the other end, you can use basically any of the tools that you might use to convert a real physical hard drive, to a simpler file. You can basically create like a sparse file. You can use QEMU's built-in tools to convert that ZVol into a QCOW2 file, and then you can handle it that way. You can just use PV or DD to make a .img file of the whole thing. Any of those methods will end up with a file or the exact same ZVol just on another machine, and you can actually mount that as a drive and mount the file system underneath it and access all your data. Now then beyond that, when you want to turn what was a VM into a container, unfortunately, I can't help you directly.
If all you're after is a couple config files, just SCP them out of the VMs before you shut them down the last time. But otherwise, yeah, I would say what Jim said is that if it's a QCOW2 file, you can use the QTOW, the QEMU-image utility to convert them to a RAW, which gives you an image file that you can just loop mount or whatever.
You can also use the QEMU-NBD utility to just mount them directly if you need to do that.
Yeah, I guess part of it depends. Like, it sounds like what he wants to do is overwrite the Proxmox machine with Ubuntu and then bring them back up. And so I don't know how much storage he has to shuffle the VMs off during the reinstall or whatever. Depending on how he'd do it, if the Proxmox pool is going to remain, you can just export that pool, install Ubuntu with those drives disconnected, and then connect those drives and import that pool again and have all your VMs exactly how they were, and just deal with, like Jim said, recreating those XML files to be able to get the VMs back up, and then, convert them one at a time. And once you're happy with the convert to a container, you can delete the VM or whatever to get some space back. But yeah, if they're image files, then you can use the QCOW or the QEMU image tool to convert them to RAWs that you can loop mount, and then you can mount them as, the EXT or XFS or whatever the file system inside the VM was.
But again, don't do that. If that's what you want, don't convert the whole thing to a RAW. Just use QEMU-NBD to create an actual block device that's, based on that QCOW2 file, and then you can mount it directly. You don't need to go through that long, laborious conversion process first.
Right, well, we'd better get out of here then. You can email your questions in for Jim and Alan to show@2.5admins.com. You can find me on Twitter @Joe Ressington.
I'm @JRSSNet.
And I'm @Alan Jude.
We'll see you next week.